Good afternoon, everyone. My name is Thad Haroon. I'm the chair of the physics department here at Brock University. Welcome to a very cloudy, overcast, dreary eclipse day here for Eclipse on the Escarpment. Um, we're all sitting here waiting for the sun to make its appearance and then the moon to shortly follow after. I'm glad you're following along on the YouTube live feed. Welcome.
Hey, I'm Justin Steep with the Dean's Office in the Faculty of Math and Science at Brock University, and I'm just going to give you a quick safety announcement. So just for all those out there, if you happen to be looking towards the eclipse today, looking directly at the sun with the naked eye or through any device or filter other than ISO 13212-2 certified eclipse glasses may cause permanent damage and even blindness. So we want you to be careful out there. Sunglasses, regardless of their darkness, are unsafe for eclipse viewing. Brock University does have free certified eclipse glasses while supplies last on campus if you happen to be joining us today at a number of locations on campus, which you can find on our website. And if you plan to purchase your own glasses, just make sure that they do have that ISO 12312-2 safety rating. We also recommend, if you don't have glasses, is to use a pinhole projector or box projector. You can find instructions for those on our website as well. So, if you do happen to have your glasses and you're on campus today, here's some instructions, the easiest way to do it. First of all, turn away from the sun and locate your shadow. With your back to the sun, place your eclipse glasses over your eyes, ensuring you can't see anything through the filters, and be aware of your surroundings. With your eyewear in place, now it's time to turn towards the sun and locate the now fainter sun. But if you struggle to find it, just have someone help you. During full totality, when the sun is totally blocked by the moon, which is about 3 minutes long and will happen from 3:18 to 3:21, it is safe to briefly remove your eclipse glasses. Recommend putting them back on before totality concludes, but when in doubt, just keep them on. We have some amazing educational booths here at Brock today. One of them, Animal Behavior During the Total Solar Eclipse. By the Center of Neuroscience, they've created an educational poster describing some published observations that show animal behavior during the 2017 total solar eclipse in the United States, including some observations made at the Riverbank Zoo in South Carolina. In the Celestial Origins of the Elements, offered by the Department of Chemistry, this educational exhibit will address the celestial origins of the elements in the periodic table and how common origins can lead to vastly different properties. Information on how the products of stars end up in life on Earth will be shared, as well as the chemical techniques can be used to study the stars without ever having to leave one's desk. Visitors to the booth will also be able to see and handle samples of some of the pure elements found on Earth, but that they started out millions of kilometers away. In Dark Shall Be Thy Sun, Imaging Eclipses in Early Modern England, offered by the Department of English Language and Literature, this educational exhibit will use 17th century poet Hester Pulter's poem entitled The Eclipse as a jumping off point to explore historical, visual, verbal, and poetic representations of eclipses. Offered by the Department of Earth Science, you may enjoy, and the Brock Geo Club, this one is called Geographical History of the Moon. This exhibit will compare the timescales of the Earth and the Moon and discuss how the Moon appeared from Earth over different periods of time. Participants can take a photo of themselves on the Moon with the exhibit's green screen selfie station. Along the Earth Science tip, Geography of Impact Craters, offered by the Department of Earth Science and the Brock Geo Club. This educational exhibit will feature an interactive experiment in which participants will make impact craters. Meteors and rock samples will also be on display. Come check it out. A couple more booths and we'll have a full complement. The Invisible Plant Symphony, observing nocturnal choreograph in plant life during the eclipse during infrared light. Offered by the Department of Biological Sciences and the Yusuf Hajimad Department of Engineering, this educational exhibit will feature a live experiment taking place during the eclipse. Oxalis plants are known to display rapid plant movement by retracting their leaves towards the shoot when kept in darkness. It is believed to be an evolutionary response to promote photosynthetic growth during the day and prevent dehydration of the leaves at night. Using an infrared thermal imaging camera, the plants will be monitored during the eclipse to see if they will be fooled into thinking they are experiencing a night cycle when the eclipse blocks the sun and turns the afternoon sky dark for 3 to 4 minutes. The exhibit will feature a poster that explains this photobiological phenomenon, a student talk, and a live video feed of the plants being monitored. Is the sun really bending space and even time? Offered by the Department of Mathematics and Statistics, this educational exhibit will discuss the Eddington experiment, which used the total solar eclipse from 1919 to confirm Albert Einstein's then 4-year-old theory of general relativity. The eclipse presents a rare chance to verify one of the essential consequences of this theory, the bending of light by gravity. Einstein predicted the stars would appear to change their position when their light passed near the sun. The brightness of the sun normally makes it impossible to see the stars in the daytime, but with a total solar eclipse turning the afternoon sky dark, stars can be seen near the sun with a telescope. We also have guest booths from the Niagara College Solar Spectroscopy, the Niagara Geopark, SETI Institute, and Space Place Canada.
Okay, so what we're looking at here is an experiment on a plant called oxalis, and we're using a mid-wave infrared thermal imaging camera that allows us to see anytime whether there's light or not, because it looks at the inherent radiation being emitted from all objects around it. And so during the peak of the totality, we're hoping to see changes in the plant's either its temperature or changes in its leaf position. Normally at night what happens is that these plants close their leaves down. Somebody's just interfering with our experiment at the moment. And they close their leaves down during the night when there isn't any light. It's an adaptive response to saving energy and maybe saving water. So we're hoping to be able to examine what happens during complete darkness of the eclipse. Audio is good? Yep. Okay. Aside from the hand in the way.
Good morning. So, who am I here with today?
Hi, I'm Henry Lowton, and nice to be here at Brock. I'm the president and co-chair of Space Place Planetarium Canada. And I'm here because I want to talk about the plans we have for a 21st century planetarium in Toronto and a virtual planetarium for Canada. We've been working since 2019, bringing all the necessary organizations together to have a planetarium. We're the largest city in the world, the largest tourist city in the world without one. And it's so important for STEM education and for tourism to give us a window into Canada's contribution in space technology and astronomy.
Wow, it's great that you guys are doing that. It is really important for us to have something like that. And could you tell me a little bit about these glasses?
Well, Space Place, like many organizations, wants to ensure that people are watching the eclipse safely. These are ISO approved glasses. These are not sunglasses, these are special eclipse glasses because even regular sunglasses will not give you protection if you stare at the sun. And every time there's an eclipse somewhere, unfortunately, people look straight into the sun and they can get permanent damage. The other thing that the glasses are good for in this cell phone age is to protect your cell phone. Cell phones need protection too. Their eyes inside the cell phone can be burned out, and you have to get new cell phone if you direct them at the sun long enough. So these glasses, which have a description of how to use them safely and all about Space Place Canada inside the glasses and on our QR code, we've been giving out to over 2,500 to agencies and schools, institutions across the Greater Toronto area and mailing them across the country for people that want to watch the eclipse safely. And we have been promoting the safe use of these glasses for the eclipse on our LinkedIn and website and all other social media. And you can reach us at spaceplacecanada.ca.
Well, thank you so much. You heard it here, folks. Protect your eyes and protect your camera lenses. Good morning. Who are we here with today, and what do you have in this booth?
So hi, I'm Cristina Simionescu, a professor at Niagara College in the photonics department, and we are here to represent Niagara College and the photonics department. It's a program unique in Canada in the college system, and it's about light technologies. Photonics means light technologies, and we are here to celebrate with everybody else the eclipse. We are very excited about it because we are telescope makers, and you can see here we brought a telescope that our students make, and that's what we are hoping to do today. We are trying to get people excited about light technologies and show them all kinds of fun things, diffraction grating, lenses, lasers, but also talk about this unique capstone project our third-year students work on, from design to prototyping to build. And we brought a couple of examples here, and just share that love for making scientific instruments. Many times technicians and technologists are the makers of the science world. We are the ones that build the instruments that scientists use.
It sounds amazing. Thank you so much.
I'm glad to be here. Thank you for inviting us.
So can you tell us a little bit about the telescope?
Absolutely. So this is called the Newtonian Reflector Telescope. I've made it for my third year photonics class, where we had to manufacture and completely design our own telescopes. Everything you see here is handmade by me. The two parts themselves are all 3D printed and designed in a software that can make 3D objects. And then the actual mount itself is fully cut up wood pieces that I've put together. I've got my own bearings and my own equipment and made a working telescope out of it.
It's really awesome. Thanks. Good morning. So who am I here with today?
My name is Darren Platicus. I'm part of the Niagara Aspiring Geopark. We've been working on this project for about 10 years now, trying to get the UNESCO designation of a global geopark to the Niagara Peninsula. And a geopark can be thought of as a celebration of the intersection of geology and culture. So all of our culture in Niagara, from the earliest indigenous all the way up to today, has been impacted by the geology that we have below our feet. And so we work together to bring the education piece to grade schools, but also to the broader community about what the geology is beneath our feet and how important it's been to our culture in the area.
Wow, that sounds really interesting. And I see you guys have some rocks here.
Yeah, we have some examples of fossils that were found in the area. So these are fossils that were found at Wainfleet Wetlands Conservation Area, strictly for education purposes. I don't recommend anybody go there and start fossil collecting because it is a protected area. But we also have some crinoid fossils here, which are considered, a more colloquial name would be a sea lily. And but all of these were found in the Niagara area.
What do we have here on this table today?
What we have here on this table today is a display of materials from the 17th century from England, and it's print culture mainly. The various things people wrote and thought about eclipses that happened at the time, which were predictable at the time. They knew when they were coming, and they often were quite terrified of them, or they thought they could, make something of it politically or from a religious perspective. So we have sermons, we have diaries, we have examples of early newspapers, and we have poems as well, which is how I got started with my interest in this. I'm an English professor, so yeah.
Wow.
Yeah.
That's really cool.
Thanks.
What would you say is your favorite piece on the table here today?
I'd say my favorite piece here on the table is actually this. An enlargement from, it's a Dutch newspaper actually, but I found it such an interesting image because it shows people at an event much like this where they've assembled in order to view the eclipse, hopefully safely. Some of them are doing what we'll be doing and blocking their eyes, some are not, some are just staring directly at the sun. And some are looking in reflections, maybe a bucket of water or a mirror. So it's interesting to think that hundreds of years ago people were doing exactly what we're doing today.
It is.
Yeah.
Thank you so much.
Thanks, Timmy.
It's really interesting. What do you have going on here today?
So we're basically taking a look at where all the elements come from. We tend to think of the elements on our planet as starting here, and they absolutely did not.
Really?
The only ones that really come from Earth are the ones that are man-made. We have a periodic table here that shows where all of the elements originated from. Most are coming from a star of some sort, whether it's one that is dying, one that is growing, some that are coming together. Basically, everything starts with hydrogen and helium. You have those two, and then basically from there it is, and I don't want to oversimplify it, it becomes math. We have between hydrogen and helium enough to make every odd and even numbered element in the periodic table just by combining the two of them together in various forms. And then they travel throughout the universe, get caught up in what are called these interstellar inertials, these big giant gas clouds, and when conditions are right, they come together to make what we are standing on today.
Really? So these here are all made from various stars?
Every single one of these, yes.
Wow.
As much as they've all been isolated from Earth, they all came from out there somewhere.
Wow, that's really interesting. Thanks for letting me know.
No, my pleasure.
What do you guys have going on here today?
Okay, so right now at the station we have photochromic paint happening. That's paint that it looks like pretty much nothing interesting. It looks like it's white or just pastel colors, but when you take it out underneath the sun, it's activated by the sun's ultraviolet light. This light that we can't see, but it's what causes you to tan and sunburn. And then those paints turn into really colorful, bright colors. So it's really fun, and the kids seem to love it. So yeah.
Wow, that's so cool. Thanks for letting us know.
Thank you.
So what are you guys showcasing here today?
Hi, I'm Donovan. I'm with the Earth Science Department, and we are showing meteorites. We're also showing rocks that are from the impact craters of meteorites. We just have a booth here that we're having people be able to see them, get to hold things from space. It's a great opportunity to be able to do that.
Hi everyone, my name is Kevin Turner. I'm an associate professor in geography and tourism studies and also cross-appointed in earth science here at Brock University. And today we are measuring meteorological conditions using a weather station that we've had here at Brock. It's going to measure solar shortwave radiation as well as wind speed, direction, and also temperature and humidity. Typically, I have these things stationed out in remote parts of northwestern Canada where we're looking at how changing climate is affecting landscape up there. But we had a great opportunity to just bring the instrument out here today and just see how the eclipse affects these different variables. We need this kind of information to understand what the ground conditions are like, so that when we're understanding it from the sky, from satellites and from airplanes, we know really what is driving the change that we detect on the ground. And so if you want to learn more about that, feel free to stop by Geography and Tourism or Earth Science sometime, and we can certainly talk to you about that. But today we're just excited to be out here, part of the energy with the eclipse, and I'll leave it at that.
Right now, up on the tower, are two students observing wild spiders, seeing their behavior. They see if they spin a web today, and I think they did spin a couple webs. Even sometimes spiders, when they sense rain, tend not to go ahead and spin their webs. Many spider species eat their webs at night, and to recycle the proteins of the spider silk. And what we're curious about is whether or not these spiders, wild spiders, will actually do the same when darkness falls. So we have students perched in the archives of the library in the Brock Schmann Tower right now, observing the spiders. And we'll see what happens when darkness falls, whether it triggers a response in the spiders to start eating their own webs. This is one of the two experiments that the biology department is contributing, and probably the most likely to see a positive outcome on the question of whether animals can sense the darkness fall of a total eclipse. Just winging it. that was very exciting. That was really thrilling. But as we pack up to head out from the eclipse, we'll just check in with some of the scientists and see if we actually measured anything interesting. Did you see anything?
Well, we saw the obvious. The statue cooled, as we expected it would. But we'll have a nice time lapse of the crowds of people coming and going, and the statue cooling. Our plant experiment's going to take a while to analyze. It also cooled, but we were not quite seeing maybe the full leaf closure that we had hoped to see, but they were a little stressed from the overall cooler temperatures. But it's spurring on a lot of collaboration, so the eclipse has been a good moment for that.
And what happened to the weather?
Well, the weather was very interesting. We didn't see huge temperature drops, just a couple of degrees, but we saw a huge drop in the radiation, almost zero for a long period of time. The wind obviously didn't change much because we didn't have the wind in the beginning.
Yeah.
But it's a great experience for everybody. They was very excited to see the weather changing, and that, and hopefully we can share this data with everybody.
So we'll do a recap, gather all the data, collect it, whatever video feed we had. I apologize we didn't get much from the telescope today, but we'll do a recap video pretty soon. Thank you everyone for joining us today. That was really exciting, and I want to send a big shout out and thank you to everyone at Brock University who made this day possible with the thousands of people who came out to see this. Starting with Brock TV, thank you guys for coming out and helping out recording this for posterity, and also for the myriad of services at Brock University, conference services, campus safety, ancillary services. Took an army of people to put this on and provide a memorable experience for the public. Thank you to everyone who contributed to the science fair. That was very well received, and hopefully people really learned something new today.
Absolutely. Science is everywhere, and I think today we proved that. You know, we all had a beautiful time in the dark, and it's inspiring despite the cloud cover. I think people will remember this for their lives. I hope they remember being at Brock and experiencing what it is to see science and the beauty of nature all together.
That's right. So, very unique experience, once in a lifetime for myself. I think we'll have to take a trip to see the next one.
Yeah, I'll see you there.